Hello everyone, today in this video we'll be discussing the module 2 of BMATS101 super important questions from the exam point of view, and this video is sufficient for you to score more than 80% marks. You need to learn these topics. Okay, these topics are the ones we asked in the most repeated questions, and if you want all of the questions from the previous papers, DM me on Instagram. This is my ID, and before starting, please do like and subscribe. It helps me make more videos like this. So without wasting more time, let's get started. The questions which I have taken is from the previous year papers from the 18, 21 and 22 scheme, as well as the model papers. Okay, so let's get started with the first topic, which is Mclaurin series. Okay, in Mclaurin series you'll be given with a question like this. Okay, there will be a formula given. Okay, this formula is called as f of x. Okay, this is called what? This is f of x. When we use Mclaurin series and expand, we should get this answer. Okay, when we use Mclaurin series formula and expand, we should get this answer. Okay, that is the aim. Now f of x is given as this one. Okay, what is 1 plus sine 2x? And for this module you need to be very thorough with the trigonometric formulas. Okay, so 1 plus sine 2x can be written as 1 plus 2 sine x cos x, and 2 sin x cos x will be as such, and 1 can be written as sin square x plus cos square x. Okay, so sin square x plus cos square x plus 2 sin x cos x is nothing but the expansion of sin x plus cos x whole square, and this is under the root, so this will become sin x plus cos x. The f of x function will become sin x plus cos x. So f of x is also called as y is equal to sin x plus cos x. Now the Maclaurin series formula is f of x is equal to f of 0 plus x by 1 factorial f1 of 0, x2 x square by 2 factorial f2 of 0, x3 by x cube by 3 factorial f3 of 0, and so on. Okay, you get the point, right? This is the Maclaurin formula. You need to memorize, right? 3 or 4 times and memorize this one. Okay, so y is equal to sin x plus cos x we have. Okay, we just have to substitute 0 in the place of x. Okay, what we have to substitute? 0 in the place of x. So when you substitute 0 and 0 here, we'll be getting answer 1, and we will be differentiating this with respect to x. When you differentiate sin x, we'll get cos x. When you differentiate cos x, we'll get minus sin x. Okay, again we will substitute the place here as 0, so we'll be getting an answer that is 1 here. Okay, like that. This is f1 because it is the first differentiation. We'll again differentiate this, we'll get this answer, and in this answer, if you observe carefully, if we take the minus common, we'll be getting minus sin x plus cos x, right? Minus sin x plus cos x, but sin x plus cos x is equal to y, so we can write this as minus y also. As soon as possible, you have to convert this whatever the answer you are getting, if possible, to any of the derivatives, like how I converted to y here, right? Then it will be very simple. Y2 is equal to minus y. Differentiation of y2 will become differentiation of this one, y1. So y3 to y4, it will become y1 to y2 minus. Okay, like that we can keep on going and substituting the values of 0. For example, substituting value of 0 here in this equation, we all you have to do is, what is the value of 0 at y? 0 at y, the answer is 1, so this answer will be substituted here as 1, so it will become minus 1, so this answer will be minus 1. For this one, we'll substitute the value of 0 at y1. 0 at y1 was what? 1, so here we'll substitute 1, so it will become minus 1. Like that we'll do for all of these terms. Okay, at least till 5 or 6 terms you have to do. Okay, in the question, if they don't mention, you have to do till 5 or 6 terms. Otherwise they will mention up to x4 and so on. That question also we'll be having a look at. Okay, now by using the Mclaurin series expansion, you just have to substitute those values f0, f1 of 0, f2 of 0, f3 of 0 in this equation, and you have to simplify it, so you'll be getting an expansion which will be equal to the question which they had given. Okay, then your answer is correct. You'll be writing hence proven. Okay, let's have a look at one more question of Mclaurin series, repeated question from the exam point of view. Log 1 plus sin x. Okay, so y will be taken as log 1 plus sin x, and f of 0 is equal to 0. Okay, because if we substitute 0 here, this will become 1 plus 0 is equal to 1, and log 1 value is 0. You have to be thorough with the log arithmetic values also. Log 1 is equal to 0, and the value of log of e is equal to 1, and log of 0 is equal to, what is log of 0? Mm, log of 0, I'm not sure about log of 0, but you can refer the table book. Okay, so usually we'll be having log 1, which will be getting the value of 0. Okay, usually we'll be substituting this value. Remember this value. Okay, now will we have the y value here and f of 0 value here. Like that, similarly we'll differentiate this. Differentiation of log 1 plus sin x is 1 by 1 plus sin x into cos x. Substitute the value of 0 in the place of x, and we'll be getting the answer 1 here. Again differentiate this one, we'll be getting an answer here, and substitute the value of 0 in the place of x in this equation, we'll be getting minus 1 here. Like that, again we'll differentiate that. So this differentiation, how we did, it is u by v, right? What is the differentiation of u by v? It is nothing but u dash v minus uv dash divided by v square. This is the formula, right? That same formula we have applied here and did. Okay, so we'll be getting f3 value. Again, we'll be differentiating wherever it's possible. You can substitute y2 and y3 as well. If you go through the steps carefully, you'll get to know. And we'll be getting the f4 value also. So in this question specifically they have asked till f4. Okay, x4. So we have done till x4. Okay, now after this what you have to do is you just have to substitute the value of f1, f2, f3, f4 till f4. You have to substitute, and after that you'll be getting an value. This is your final answer. Okay, let's have a look at the last question of Mclaurin series. This is a super important question from the exam point of view. Repeated one, log sec x. Okay, log sec x, again the same thing you will be doing. You'll be finding out y1, so it will be 1 by sec x into tan x, it will become tan x here. Okay, and value of tan 0 is 0. Again you will be differentiating this one. Tan x is nothing but 1 plus tan square x. Okay, so 1 plus tan square x, tan x you can substitute it as y1 here. So what it will become, 1 plus y1 square. Okay, as soon as possible you have to convert it into the y1 values. Okay, okay, after that you will be continuing with the same thing. You'll be differentiating it and substituting the values of zeros, and you will be using those in this equation, and you'll be getting an answer. Okay, this is your final answer. The next type of question is finding out partial derivative. Okay, partial derivative is the next question. This is also very important one. So usually in the module 2 what happens is the first Mclaurin series question comes in the first part of or okay, first Mclaurin series, then comes the partial differentiation. Okay, this can come in second or also, but this usually comes in the first or as well. Okay, so the question will be as something similar to this: u is equal to f of x by y by z, z by x. Okay, and we have to show something here. Okay, so the trick to solve this is, first what you have to do, if they give you in the division form, you have to take those division form as some variables. Okay, if they give in the division form, you have to take the division form as some variables. So it will become x by y will become p, and y by z will become q, z by x will become r. Okay, after that pqr, here it will be this one. Okay, now what you will be doing is you have to differentiate each. Okay, there are how many variables are here? X, y and z. Okay, in this whole thing there are three variables, so you have to partially differentiate it with respect to x and with respect to y with respect to z. First we'll be having a look at partially differentiating with respect to x. Okay, now partially differentiating with respect to x means, first you will write du by dx. Okay, du by dx. Okay, it is actually del. Okay, but for simplicity purpose I will be calling it as d. Okay, du by dx here, du by dp into dp by dx. Okay, like that you will be writing, because first is p, right? So p you want to differentiate. First u is related to p and p is related to x, right? So du by dp into dp by dx plus du by dq plus dq by dx. The denominator will remain dx here because of this one, but first it will be p, it is, then it will be q, then it will be r. Okay, this is the formula you need to memorize. Now du by dp, the first term, this is the first term. Okay, let's solve each one by one. So this is the first term here, du by dp into dp by dx. Du by dp will remain as such, and differentiation of p with respect to x, differentiation of p with respect to x, how we will do that? What you have to do here is, what is p? The p value is x by y, right? That's what we have taken, p value x by y. So we'll substitute d by dx into x by y. Okay, so we'll differentiate this one, and this is not normal differentiation, this is partial differentiation. So in partial differentiation, any variable except x will be taken as constant. So here y is constant. Okay, y is constant. If we separate it, it will become 1 by y. Okay, 1 by y is taken as constant. When you differentiate constants, constants are taken out, right? In normal differentiation, same thing we'll do, only x is the variable. So del x by del by del x of x is equal to 1. Okay, this will become 1, so it will just remain 1 by y, 1 by y into du by dp. This was the first term. Second term we'll consider. In second term, what is the thing? Q's value will substitute here, y by z. Okay, both are constants because we are differentiating with respect to x. Y and z both are constant, so its value will become 0, so the whole answer will also become 0. The third term was del r by del x. R was z by x. X is not a constant. Okay, and z is a constant. So if a constant is there like 2 by x, d by dx of 2 by x, what we will be doing? We'll take 2 outside and we'll differentiate 1 by x, right? So the same thing here also we'll be doing. We'll be taking the z outside and we'll be differentiating this one. Okay, normal differentiation, u dash v minus u into v dash divided by x square. Okay, so when we simplify this one, we'll be getting this answer here. Okay, just keep it as such. Now we have got the value of du by d r, du by d q, du by dp. Okay, these three values we have got. We'll be substituting these values and adding it up to get du by dx. Okay, that was our main aim, right? So we'll be adding it up and we'll be taking du by dx as ux. Okay, so ux will become this answer. Now we'll multiply both the sides with x. Why? Because we don't want square in the denominator, so we'll multiply this whole term by x and this whole term also by x. LHS RSS both we multiplied by x, it doesn't make any difference. Okay, so x ux will become this one. Okay, next, similarly we'll do for y also, du by dy. That will be nothing but du by dp into dp by dy. Here the y is taken into consideration, then q by y and r by y. Okay, the same thing we'll be doing, dp by dy. What was p? P was x by y, right? X by y we are differentiating partially with respect to y. Now when we partially differentiate with respect to y, what will happen is this will remain constant, x will remain constant, x will be taken out, and y 1 by y differentiation will happen. Okay, so we'll be getting this answer here. For the next one we'll be getting this answer here. Okay, for this one we'll be getting this answer here, and this will be 0. Why? Because it is z by x or x by z something, so the constant value will be means answer constant values differentiation is 0, so we'll be keeping it as such. Okay, next, after we have got this answer, there is square here, right? So we'll be multiplying it with y, both the sides. Okay, the actual reason why we multiply by x and multiply by y is because in the question they had given, right? What is the question given? The question they have given, right? First find out this value and multiply it with x, then find out this value, multiply it with y, find out this value, multiply it with z, then we'll add these three terms and then see if the answer is 0 or not. So that's why we want this particular term, so that's why we are multiplying with y. Also that serves the purpose of removing the square from the denominator. Both of them happen parallelly. Okay, like that we'll do for z also. Okay, this is the z part here. Okay, same thing we'll do for z also, and multiply with z, we'll get an answer here. These three answers we'll multiply. Which three answers? 1, 2 and 3. Z u z, y u y and x u x. Okay, when you add these three values, we'll be getting an answer 0 here. Okay, you can verify it. Okay, so this is the thing which we needed to prove. Okay, in the partial differentiation, this is the steps you need to follow. First you need to look at the question what they are asking and you have to get those terms. Okay, let's have a look at another super important and repeated question, which is u is equal to e power ax plus by f of ax minus by. Prove that b into del u by del x plus a into del u by del y is equal to 2abu by using concept of composite function. Okay, this is the also the same type of question. Here what they are asking, del u by del x. Okay, and we have to multiply by b. So what is our first step? First step is to find out del u by del x, then multiply by b. Okay, same thing we'll be doing. Now what is u they have given? U is this value here. So u is this value, partially we differentiate with respect to x. Why we are doing that? To get this value. Okay, when you differentiate with respect to x, this value will be expanded as follows. Okay, so what's happening here? This is one term and this is another term. Okay, when we differentiate with respect to x, all the other terms will remain constant, only the x value will remain x means variable. Okay, so when we differentiate this both the terms, it is u and v. Okay, means this is one term, this is another term, so u dash v plus uv dash. Okay, that is the how we do the differentiation. So u v dash, when we do v dash here, we'll write f dash of x ax minus by, and we'll differentiate this one again. When we differentiate partially with respect to x, again this one, we will be getting an answer a here. So that answer we have written a here. Okay, after that this is u dash v. Okay, so v will remain as such, and u dash will differentiate this one, so it will be this one only, because e power x differentiation is e power x only, but instead of x we have ax plus by, so we'll again differentiate ax plus by, so we'll get another answer here a. Okay, because of this the answer will be coming here as a. Now this term, if you observe, this is equal to nothing but u. This is the u value, right? See, if you observe carefully, both are same. So instead of this, I'll substitute u here, so this will become a into u. Okay, and this will remain as such from here. Okay, and we'll be multiplying b by both the sides. Why we are multiplying b? Because in the question they have asked. Okay, very simple, we have got this answer, we'll multiply by b to get this term. Okay, so we'll multiply by b and we'll get an answer here. right? Then we'll differentiate 1 with respect to y. What is 1? 1 is this one. We want del u by del y, next thing, right? So we'll differentiate with respect to y, and then we'll multiply a also. Okay, so when we do that, I'll not be going through the steps here. When we do that, we'll be getting an answer here, this one. Okay, after that, we'll be adding both the terms 2 and 3. So when we add both of the terms, we'll be getting b du by dx plus a du by dy is equal to 2 abu. This is the thing which we need to prove. Okay, so what happened here? This term got cancelled with this term. Okay, this is a positive term, this is the same negative term. So these two got cancelled. ABU got added with ABU. Okay, so it is 2 ABU. Okay, the sequence you got to know, right? First, what we have to do, we have to find out what they have asked to prove, find out these values, then just add up, and if you get the same answer, that means your steps were correct. Okay, now again, there is means minus is there. So if there is a division or minus between two variables, you have to make it as one variable. That's the first step. So first step, we'll be making it as one variable. After that, we'll be finding out the differentiation with respect to x, y and z. Okay, so x, y and z, this will become ux. So when we differentiate this, it will be du by dp into dp by dx. This will be q, this will be r. We'll do the same thing which we did in the first question. Dp by dx, we'll find out the answer is 1 here, this is 0, and this is minus 1. When we do that, we'll be adding it up and getting an answer here. Okay, that is du by dx. We have to find out du by dy and du by dz. Du by dy answer will be this one, and du by dz answer will be this one. When we add these three answers, we'll be getting an answer 0 here. Okay, that's what they have asked in the question. Okay, so we'll be writing hence proven. Moving on to the third super important topic, which is function extremes. Okay, in the first or question, usually it happens Mclaurin series comes, then the partial differentiation, and the third one is function extremes. Okay, this is also very simple topic. You have just have to remember two concepts here. Okay, the first thing, find the extreme values of the function. The function will be given. Okay, your first step is to write the function as such, however it is given. Okay, your next step is to find out del f by del x, del f by del y. Okay, differentiate partially with respect to x and differentiate partially with respect to y. When you differentiate partially with respect to x, all the other terms including y is treated as constant. So x cube will become 3x square. This will become 0 because it's a constant. When we differentiate partially with respect to x, this will become 3, and this will become 0, this will also become 0. Like that for the y also we'll be doing, and we'll be obtaining an answer 3y square minus 12. Now after you have found these two, the third step is for maxima and minima, df by dx is equal to 0, df by dy is equal to 0. Substitute these two values. Df by dx we have got this one, and df by dy we have got this one. You substitute it as 0, you'll be getting x and y values. Okay, so x is equal to plus or minus 1, y is equal to plus or minus 2. Okay, your fourth step is to write the values of a, b, c. Okay, this is the formula which we need to use. What is a, b, c? A, b, c is nothing but del square f by del x square. That means the df by dx value which you got, again differentiate this with respect to x. Again differentiating with respect to x, what we'll get, this will become 2 into 3, 6x and minus 0, so it will become 6x. So del f square by del x square is equal to 6x. And the next one is b value is del square f by del x del y. In del x del y, what we do is we'll be differentiating this with respect to y. Okay, already x is there, differentiate this with respect to y, or differentiate this with respect to x. Both answer will come as same. If you differentiate this with respect to y, this will be constant, this will be constant, it will become 0. Differentiate this with respect to x. With respect to x means this is constant, this is constant, answer is 0. In both cases answer will be same, so you can write any of those answers, it will be 0. The c is del square f by del y square, means this one you will be differentiating with respect to y. When you differentiate with respect to y, this will be 6x, I mean 6y, right? 6y minus 0, which is 6y only. Okay, so you'll be writing 6y here. After you have done that, your last step is to make this table. You'll write points which we have got. We have got, right, plus or minus 1 and plus or minus 2, which is nothing but x and y values. So combinations which can form is minus minus, minus plus, plus minus, plus plus. Okay, after that you'll find out the a, b, c values by substituting the x and y values in these equations. Okay, here x value is only there, so you'll substitute the x value as minus 1 here. If you substitute minus 1, we'll get as minus 6, which is less than 0. B also will substitute, okay, b is 0, so we'll keep it as 0 only. And c also will substitute the value of y, minus 2, so minus 2 into 6 is minus 12. We have got the value of a, b and c. Find out ac minus b square, you'll get an answer here. Keep all these answers same, means keep it as such. Okay, now based on these answers we will find out if it is a maximum or minimum. Very simple trick, I will say how to find out if it is a maximum or minimum. the answer can be either maximum or minimum, or it can be saddle. Okay, saddle means not valid. Okay, when it will not be valid, whenever this answer, whatever we get answer, it is less than or equal to 0. Okay, remember, if it is less means useless, right? Less means useless, useless means not valid. Okay, when this value is less than or equal to 0, less than or equal to 0, it will be saddle. Saddle means useless. Okay, or if a's value will be 0, in that case it is saddle. Okay, saddle means useless, and useless values cannot be maximum or minimum. Only when this value is greater than 0, it should be strictly greater than 0, not even equal to 0, it should be greater than 0, and a also should not be 0. Okay, both these cases, if it is greater than 0, then only we'll check a. If it is not greater than 0, then it is already saddle. Okay, so if it is greater than 0, then we will check a value. Okay, now a value is what? -6, which is less than 0. If a value is less than 0, it is maximum, it is reverse. Okay, this one is greater means it is valid. Okay, it has maximum or minimum, then we will check a. If a is less than 0, it is maximum, and in this case also it is more than 0 here, so we'll check a. Check a is greater than 0 means it is minimum. Okay, you just have to do it the reverse way. Okay, let's have a look at another similar question which is repeated in the exam question papers. Extreme values of the function f of xy. This function is given to us. Write this function here: del f by del x, del f by del y. Find out the maxima and minima for both of these, and we'll find out the I mean, after finding out means after substituting these values as 0, we'll do each of these separately. Okay, so this is a smaller one, so we'll do this first. Okay, so what we got here, del f by del y is minus 6xy minus 6y is equal to 0. So we'll take 6y as separate. Okay, 6y when you take as separate, we'll get x minus 1 is equal to 0. 6y into x minus 1 is 0. Now either this is 0 or this is 0. If this is 0 means x is equal to 1. If this is 0 means y is equal to 0. You've got two values, x is equal to 1 and y is equal to 0. Both these values one by one will substitute. Y is equal to 0 will substitute in this equation, so we'll get an answer for x values. Two x values will get, and then we'll substitute x is equal to 1 in this equation, we'll get two y values, which is plus and minus 1. Now the combinations which we got, 0 with 0 and 2 with 0, so 0 0 and 2 comma 0. This combinations we got minus 1 comma 1 and I mean 1 comma minus 1, 1 comma 1. Okay, x and y we have to write in the form x and y. So 1 comma 1 and 1 comma minus 1, and this is 0 comma 0 and 2 comma 0. Okay, so this is the points which you got. The next step is to find out ABC values: del f square by del x square, del square f by del x del y, del square f by del y square. This how we will do. We have the value of del f by del x, right? Differentiate with respect to x, we'll get del square f by del x square. Okay, this is the a value. If you differentiate with respect to y, we'll get the b value, which is del square f by del x del y. If we differentiate this with respect to y, we'll get the c value, which is del square f by del y square. Okay, so we'll get these three values. That three values will be substituting it here, and after that these points values will be taking it to the table, and each one by one will be substituting a values, b value and c value. Find out this value, and then we'll compare. If it is less than 0 means it is saddle. If it is greater than 0, we'll consider it. We'll check the a value. A is less than 0 means maximum. A is greater than 0 is it is minimum. Okay, and also they had asked the question that find out the minimum value at. Okay, they are not asking anything here. So this is the thing. Okay, you'll have got these values here, and the maximum and minimum value we have got here, like it is maximum at this point and minimum at this point. But what is the maximum value, what is the minimum value, in case they ask in the question, that also. Okay, then you have to do the following step. Easy. What you have to do, you have got 2 points, right? This is for the maximum, this is for the minimum. To find out the minimum value, we'll substitute the value of 2 and 0 in the place of x and y in the original question. In the original question, substitute the value of x as 2 and y as 0, and you will get an answer. This is the minimum value. Okay, if you want to find out the maximum value, substitute 0 and 0 in the main question. Okay, you will get a value which is the maximum value. Okay, in case they ask, then you have to write, otherwise you can skip this one. Okay, the next super important topic is the evaluation of limits. Okay, very simple topic. You just have to follow some steps. Okay, the first thing is they'll be given this question. Okay, this question usually comes in the or first part. Okay, after or the first question, like ABC will be there, right? After or first question which comes here, usually it is this type of question, evaluation of limits. Okay, so here we'll be taking this same question here, we'll be writing it as such, and then we'll be substituting 0 wherever x is there. Okay, if you substitute it as 0, this will become a power 0. A power 0 is 1, b power 0 is 1, c power 0 is 1, d power 0 is 1, 1 plus 1 plus 1 plus 1, 4. 4 by 4 is 1, so this whole value will become 1 and raised to 1 by x. What is x value? X value will substitute it as 0, right? So 0, so 1 by 0 is nothing but infinity, so it will become 1 power infinity. Okay, 1 power infinity is not possible to calculate, so we have to evaluate the limits. Okay, that is the first test you have to do, if it is possible to calculate or not. How you will do the evaluation is, first you will take the log value. Okay, logarithm of here and here. Okay, log L will be equal to limit x power 0 log of this whole thing. Okay, now log of this whole thing 1 by x will come here, and log of this thing. Okay, log of this thing you will keep it as such, and log a by b. What is log a by b? Log a by b is nothing but log a minus log b, right? Log a minus log b. So we'll do the same thing, log a minus log b, and this value is 0. And after this point, we'll substitute the value of 0 and again check. Okay, after substituting the value of 0, you'll be getting here as 1 plus 1 plus 1 plus 1 is equal to 4. So here we're getting log 4. Log 4 minus log 4 is 0. So 0 divided by x value, we're substituting it as 0. 0 by 0. Okay, if this question comes, we have to apply the L'Hospital rule. Okay, again from the start, first this question you will get, apply the value 0. If you get answer like this infinity kind of thing, you'll be having to take the logarithmic value in both the sides. You take the logarithmic value, reach after 2 to 3 steps, and again apply the value 0. You will get an answer 0 by 0. That means you have to apply the L'Hospital rule. L'Hospital rule is nothing, you just have to differentiate this with respect to x, differentiate this also with respect to x. That's all. Okay, when you differentiate this with respect to x, we'll be getting 1 by ax bx cx dx. Okay, and again differentiating this, we'll be getting this answer here. Okay, the normal differentiation. Okay, normal differentiation of log of something. Okay, what we'll do, log of something is 1 by something into the differentiation of something. Okay, again the same thing we'll get, and log means differentiation of x is 1, so we'll keep it as 1 only here. Next, after that, the answer just we have as this one, because divided by 1 is nothing but this only. So again we'll substitute the value of x as 0 here, and we'll be finding out the value. When you substitute the value of x as 0 here, a power 0 is 1. Okay, 1 plus log a, 1 plus 1 into log b, 1 into log c, 1 into log d. Okay, and here also 1 plus 1 plus 1 plus 1, which is 4. Log a, log b, log c, log d divided by 4, you'll get this answer, right? So 1 by 4 can be taken it here, and if it is like this, a log x, okay, it can be written as log x power a. Okay, this we already know, so we'll be writing it as such, log abcd, because log a plus log b plus log c plus log c plus log d is equal to log abcd. Okay, multiplication. This is the formula for the logarithmic values. Now 1 by 4 will be taken it up here, 1 by 1 is taken here, and it is abcd power 1 by 4. Both the sides log is there, just cancel log values, L value will get. This is the final answer. Okay, now a variation of this same question can come, where you will be asked ax plus bx plus cx divided by 3. Same steps you need to follow, just you will have 3 in between. Another type of question which can be asked is ax plus bx divided by 2. Here also the same thing you need to do. Once you practice this one, the rest two will also be easier. Just practice that also if you have time. Okay, and since this is similar to the above question, I'll not be discussing that. I'll be discussing this one. Okay, tan x, how we need to solve. If they ask any trigonometric functions, we'll have to approach it in a slightly different manner. Okay, let's have a look. So how do we do the limit of tan x by x? Okay, so the first thing, let k is equal to limit of tan x by x power 1 by x, and you'll take log in both the sides. When you take log in both the sides, and we'll be getting 1 by x here, because of log we can take it as 1 by x here, and log tan x by x. Okay, so it will become log tan x by x divided by x. Okay, now here if we apply x value as 0, what will happen? This will become 0, and this will become 0. Log 0 by 0, it will become 0 by 0. Okay, this is not a valid one, so we'll apply the L'Hospital rule. Okay, in L'Hospital rule, what we'll do, we'll differentiate the numerator and denominator by x. Okay, differentiation by x, differentiation by x. So differentiation of this by x will become 1, differentiation of this by x will become 1 by tan x by x into this value here. Okay. And limit of tan x by x, if we put the value 0. Okay, again we'll be putting the value of 0 and checking. Okay, always we'll be putting the value of 0 and checking in the place of x. Tan x is 0 and tan this also is 0, but there is a formula in which we'll be getting this answer equal to 1. Limits of tan x by x. Okay, you have to refer to the formula where the limits of cos x, sin x, tan x is equal to 1. Okay, those formulas you have to memorize. Okay, in those formulas, one of these formulas is this one. Okay, tan x by x is equal to 1. You can refer the official video notes in which there you will be getting the formulas for all trigonometric functions for limits. Okay, so this value is equal to 1. Okay, so this value will substitute it as 1. After that we'll substitute the values here as 0. Okay, we substitute here as 0, you'll be getting 0 by 0. Okay, so this again we have to apply L'Hospital rule. Again differentiate the numerator and denominator with respect to x. This will become 2x, x square will become 2x, and this value will become this one. Okay, on further simplification we'll be getting sec square x tan x. When you substitute the value of x as 0, we'll get a final answer as 0. So here we are getting a normal answer, not 0 by 0 or infinity or something. We are getting a normal answer. When we get a normal answer, the problem is reached the end. Okay, so you take log e is equal to means this is the logarithmic. E will be the base. Okay, and k, see we have taken log k, right? So log e and the k is the value here is equal to 0. This means that e power 0 is equal to k. Okay, we have to write it like this: e power 0 is equal to k. Log k is equal to 0 means log e power 0. Okay, e power 0 is equal to k, and e power 0 is nothing but 1, so k's value will become 1, and this is the final answer. Okay, moving on to the last super important topic of the module 2, which is Jacobian question. Okay, this usually comes in the last part. Okay, either in the 4c or 3c, like that. Okay, 4c or 3c, in any of the, or it can come, mostly it has come in the 4c. Okay, the second part or last question. Okay, so one of the super repeated question is u's value they have given here. Okay, and v's value is given here, and w's values they have given here, and find out the Jacobian del u v w x y z. Okay, don't confuse this with the partial differentiation where del u by del x only will be there. Okay, here if three terms are together, okay, this is Jacobian, or else they will mention it as Jacobian here. Okay, and this will be divided by del x del y. Okay, here it will be like uv divided by del xy. Okay, two consecutive terms are there. This is the Jacobian question. Okay, now in this question, one simple thing you have to do, you just have to know the partial differentiation. U's value is given here. Differentiate u with respect to x, y, z. Okay, partially differentiate with respect to x, we'll be getting 2x here because the rest of the things are constant. This will be 2x. Partially differentiate with respect to y, we'll be getting 2y. Partially differentiate with respect to z, we'll get 2z. Same thing do for v also. V with x, v with y, v with z, w with x, y, and z. Okay, we'll get these answers. These answers you have to substitute in this equation. Okay, this is ux, uy, uz, vx, vy, vz, ws, wy, wz. You have to substitute it like this. Okay, then you have to do the matrix elementary row operations where you can subtract it or you can directly expand it also. You know the expansion of the matrix, right? This one into this minus this. Okay, minus this one into um, this into this minus this into this. Okay, like that we can do, but for the simplification purpose there is a common 2 here, right? So we'll take 2 as common. Okay, from c2, and we'll do r2 is equal to r2 minus r1. Okay, so this is r1 row 1 row 2 row 3, r1 r2 r3, and this is column 1 column 2 column 3. So this is c1 c2 c3. Okay, we'll take common as 2 from c2 c1. Okay, so we'll get 2 here. Now r2 we are doing r2 minus r1. Okay, r2 is equal to r2 minus r1. What we are trying to do, we are subtracting this one with this one. Okay, we are subtracting this with this one, subtracting this with this one, and storing it here only. This is a valid elementary operation. Why we are doing it? Because we want 0 here. When you subtract 1 with 1, it will become 0 here. Same thing we'll do with this also. This row will be subtracted with this row. Okay, this minus this. Okay, so this will become 0. This will become x minus z. This will become z minus x. Okay, like that we have written here. Okay, and these two values become 0. Next, again taking common x minus y and x minus z from r2 and r3. From r2 and r3 we are taking x minus y as common. If we take x minus y as common from here, this will be minus 1. Okay, why? Because x minus y into minus 1, what is it? X, see, x minus y into minus 1, when you do, what will happen? Minus x plus y. If we rearrange, it will become y minus x. Y minus x is nothing but this. So if we take x minus y common from this row, this will become -1, this will become 1, and this will be 0 only, because from 0 we can take anything, right? And because anything into 0 is 0 only. So x minus y we have taken from here, so the answer will be -1, 1, and 0. And we'll take x minus z common from here. This will be -1, this will be 1, this will be 0. Okay. After that we'll be writing it here, and we'll be expanding it very easily. We can expand, we'll keep 1 as here, and we'll be multiplying -1 with 1, minus -1 into -1. -1 into -1 is 1, so it will become -1 plus 1 into 1. Okay, 1 is from here, and -1 is from this one. Minus of -1 is +1. Okay, expanding across C3. This is the elementary row operations. Okay, I hope you know this. This was in the 12th standard PUC max, right? So 1 into -1 into 1 minus 1 into -1. Okay, -1 into 1 minus 1 into -1. So this will be -1 plus 1, which will be 0. 1 into 0 is 0. So this answer, when we expand it from here, this whole answer will become 0, and 0 will be multiplied with this one, so it will become 0. The final answer which you got is 0. So the value of Jacobian is 0 in this for this question. Okay, this is what you have to write. If you still didn't understand, let's solve another question here. So use value is given as this, v value is given as this, w value is given as this. You have to find out the Jacobian at this values are also given to us. Okay, again the same thing, u v w will be writing it here, and we'll be finding out the partial differentiations. After that we'll be substituting those values here, and they have given the values of xyz as 1 minus 1 0. So we'll be substituting the values of xyz as 1 minus 1 and 0 wherever it is. After that you'll be getting this value here, and you'll be expanding it with any rows or columns. Okay, means 1 into 0 into 0, minus -4 into -1, plus 0 into -6 into 0, minus 1 into 0, and 1 into plus 1 into -6 into -4 plus 0. Okay, minus 0. Okay, so when you do that, means the values, when you do, you'll be getting the final answer as 20. Okay, so this is the final answer for the Jacobian. Okay, it's very simple question. You can solve 2 or 3 more questions from the VTU notes. And that's all for this video. Don't miss any of these questions. These are super important ones. And please like and subscribe. It helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.